Hi everyone, welcome to my channel Math Changer, a game changer, the place where maths becomes simple, clear, and even fun. Whether you are preparing for exams or brushing up on the concepts or just curious about how number works, you are on the right spot. Here we break down the tricky problems step by step, explore smart shortcuts, show you how maths connects to the real life. So grab your notebooks, sharpen your pencils, and let's dive into the world of numbers together. Don't forget to subscribe and hit the bell icon so you never miss a lesson. Let's get started. Today I thought we'll cover up the topic fractions, which starts from grade 3 till grade 8 of across all boards, whether it's CBSE or ICSE or even IGCSE. There are so many boards right across the world. Everywhere, the grade 3 till grade 8, even in IGCSE and GCSE syllabus, we have fractions till grade 10 as well. So very important topic. Let's learn it. So let me take an example. So we have a pizza, right? In pizza, how many parts do we have? It depends, right? So some pizzas have 4 parts. So fraction is actually a part. So for example, if I shade this represents what part of the whole? So this you've shaded one out of how many parts? Four. So the fraction becomes 1/4 or 1/4. So fraction means a part of the whole. So it can, if you shaded the other one too, this become 2/4, which later on we'll learn how to reduce it to the lowest term. You can even cancel, and that means half of the pizza. You have shaded half of the pizza. If you shade another one, that's become 3/4. And if you shade the last one as well, that becomes 4/4. Basically, the whole pizza. So fraction means a part of the whole. And we'll also learn that various type of fractions. So one of the fraction is, for example, this fraction. This is proper fraction. Proper. So what does that proper fraction means? When your numerator is lesser than the denominator. So we know that, right? This is called numerator. The one above this sign. The one above this sign, the number above this sign is the numerator, and this one is the denominator, right? So whenever the numerator is lesser than the denominator, or you can say other words, when the denominator is bigger than the numerator, those fractions are known as proper fractions. Now, what are improper? We have another type, improper fractions. Improper. Improper means when your numerator is bigger than the denominator, like 9/7, 5/4. Here, the numerator is bigger. And we have a third type of fraction, which is mixed fraction. Mixed fractions can, only the improper fractions can be converted into mixed fractions. So basically, you would have seen fractions like this: 3, 2/4, 4, 1/5, where you have something in the front like this. So all your improper fractions can be converted to mixed fractions. For example, if I take an example, uh, 3/4, what type of fraction it is? It is a proper fractions cannot be converted. Okay, proper fractions cannot be converted to mixed fractions. Only the improper one can be converted. If I take 4/3, just the inverse of it, which is improper, we have just learned the definition of proper and improper, right? The proper fractions where the denominator is bigger than the numerator, and improper fractions where Your numerator is bigger than the denominator, and only improper fractions can be converted to mixed fractions. So in grade 3 and grade 4, we learn about all these things, and we also learn about converting them to mixed. So we learn, and also we learn how we can convert any fraction, um, equivalent fractions, all those things we're gonna study. What I'm basically trying to cover up over here is, let's learn the basics, and then gradually we'll keep on building up. As I told that we will gonna learn fractions, right from the grade 3 till grade 8 of CBSE and ICSE syllabus. So what we'll do is we'll start with the grade 3 level, and then we'll keep on gradually building up, because fraction is a very very important and a very wide chapter altogether. So how can we convert 4 upon 3 to a mixed fraction? Let's learn. So always divide, though it's very simple, but yeah, the one who are just the beginners who just want to learn how we can convert improper to mixed fractions, this is how we do. The denominator will become the divisor, and the numerator will become the dividend, and the denominator will be the divisor. Divide it. So 3 times 1 is 3. So this is your quotient. This one is your remainder. So how will you write it? Always remember, mixed fraction is always of this type. Quotient in the front, remainder in the numerator, and the divisor in the denominator. Or basically, whatever was the denominator before, same will gonna come here. So this will gonna become what? 1, because 1 was your quotient. What is the remainder? 1, and then the denominator will be the same what it was before, or you can say the divisor. So we have converted 4 upon 3, which was an improper fraction, to a mixed fraction, which is 1 upon 3. Let's do one more. So let me take 16 over 5. So how we will convert this improper fraction to mixed fraction? So again, the same thing as I told you, the numerator will be the dividend, and 5 will be the divisor. Dividend means the one which comes inside this. I will also take a small class after, some after this video, to explain how we do the division and multiplication for the lower grades, so that if we know how we divide. So if we'll take a 16 here, and we have a here 5, we just discussed, and just divide it. So 5 times 3 is 15. We subtract, and we get a 1 as the remainder. As we already know, this is the quotient, this is the remainder, and this was the divisor. And we always write mixed fraction like this. Please write it down. QR upon D, where Q is the quotient, R is the remainder, D is the divisor. Basically the same what it was before. You can even just write 5 here. And what was the quotient here? 3. And what is the remainder? 1. So we converted 16 upon 5 to a mixed fraction, 3 upon 5. Isn't it so easy? Yeah. Okay. This is one thing. So we learned about the fractions like proper, improper, and mixed fraction. And we also learned how we can convert the improper to mixed fraction. Now let's learn about the equivalent fractions. Once again. Yeah. See, if you read this word, the meaning is in the word itself. Equivalent. Equal. This word comes from equal. Valent. This val. This val means value. So the fractions which has the equal value are equivalent fractions. The word itself is very self-explanatory, right? So EQ from equal, VAL from the value, and that's how they become equivalent fractions. For example, if I write one fraction, 2 upon 4, I write another fraction, 1 upon 2. Are they equivalent? By looking, it doesn't look like, right? Because this is 2 upon 4, this is 1 upon 2. How can that be equivalent? But always remember, we have to reduce any fraction to the lowest term. And then we can decide whether the fraction is equivalent or not. Now let's learn how we can convert any fraction to the simplest form. Then only we can understand the equivalent fractions. So for example, 2 upon 4. See, that's how each and every chapter is connected. So here also, though we are learning SCF, the fractions chapter, SCF LCM concept is related. If you know what is SCF and what is LCM, you can refer to my previous videos. But HCF, let me have a, give you a small idea about it, because very important that we should know what HCF is. As we some books also refer it as GCF, the greatest common factor or the highest common factor, the one which divides both of them. Even one divides. Is it there any other number? Two divides. Two divides both of them. Is there any other number? No. Two is the highest number which divides both of them. So that's the highest common factor. So what are factors? If you come to know about that, then the game become easy. Factors means in which old multiplication table that number comes. For example, if I take an example of 15, so what are the factors of 15? So 15 comes in the table of 1. Does it come in the table of 2? No. 3, because 3 times 5 is 15. It comes in the table of 3. It also comes in the table of 5. Anything else? No 6, no 7, no 8, no 9, no 10, no 11. I think then straight away 15. Always remember, 1 and the number itself will always be the factor of any number. And beyond that, you won't get. 15 will be the highest factor of 15. So the number itself will always be the highest factor of that number. Yeah. So 1 and 15 are default factors, and 3 and 5 we just figure it out because 3 and 5, in the multiplication table of 3 and 5, 15 comes. So 3 5s are 15, 5 3s are 15. So 3 and 5 are also the factors. Now let's learn about. I'll take another example like 12. So what are the factors of 12? So factors of 12 are 1, and we already know just 12 will be the highest factor of 12 because the number itself will be the highest factor. Then it comes in the table of 2. It comes in the table of 3 as well. Yes. Then it comes in the table of 4. Yes. Anything else? Yeah, 6. Okay, so how many factors of 12 we have? 1, 2, 3, 4, 5, 6. And how many of we have here? We have just 4 factors. Now, how we find out the highest common factor? So what are the common factors first of all? 1. Sorry, we are deviating from our main topic fractions, but yeah, very important that we should know a little what you can say, the little info about what the factors are and what's ICF. Then this, learning this equivalent fractions concept will become easier, isn't it? So 1 is a common factor. What else? Yes, 3 is a common factor. What else? Nothing. So the common factors are 1 and 3. So out of 1 and 3, which is the highest? So that is how you can say highest common factor of 15 and 12 is just 3. to learn this LCM concept, you can please refer to my previous video. That will definitely will help you all about the concept. I will again cover it, but as of now, no, because we are covering up the equivalent fractions where SCF concept is very important. So similarly, the 2 and 4, the highest common factor is 2. Always divide by 2. I always divide with the highest common factor. This become 1, 2 divided by 2 is 1, and 4 divided by 2 is 2. 1 upon 2, and this was also 1 upon 2. Now we can easily can say these 2 upon 4 and 1 upon 2 are nothing but equivalent fractions. So to figure it out whether any two fractions are equivalent fractions, we have to reduce them to the lowest term. Otherwise, we cannot figure it out. This is one way. Or else you can also do one more thing. Let me, if we don't want to reduce to the lowest term, you can do one more thing. For example, let's take an example, 7 over 14, and you have mm, 14 upon 28. Are these equivalent? By looking at, yeah, we cannot figure it out. Either we should reduce to the lowest term, or else the method which I'm about to discuss. You can make the denominator same. So how can you make the denominator same? You can take LCM of 14 and 28. See, that's what I was telling. Each and every chapter is linked to somewhere, and so it's all linked. Even when you're doing algebra, the integers concept will be somewhere connected. You should have a thorough knowledge of integers. Then only will you be able to subtract the like fractions, all those stuff. So everywhere, some in maths, every concept is linked. So we are doing here the equivalent fractions. We just discussed the HCF, and now we are discussing the LCM. The LCM of 14 and 28 is basically 28. So how can you make 14 equal to 28? Multiplying by 2. This become 28. And how can you make 7 equal to 20? Whatever you multiply with the denominator, same thing you need to multiply with the numerator. Very important. And vice versa. If you're multiplying something with the numerator, you have to multiply the same with the denominator. So this become sorry, so this become 14 over 28, which is the same like the other fraction. So yes, sorry, that they are equivalent fractions, isn't it? So we learned two techniques to prove any two fractions equivalent. Either we can reduce them to the lowest term, or else we can make the denominator same. For example, if I would have taken some other fraction like 5 upon 14, and instead of 7 upon 14, I had 5 upon 14. So I'll take an LCM of 14 and 28, which is 28, and I have to make the denominator same, right? So I will multiply 14 into 2 to make it 28. And same thing, you need to multiply with the numerator as well. So that becomes 10 upon 28. Now this is 10 upon 28. This is 14 upon 28. They are not same. So they are not equivalent. This is how we can figure it out whether the fractions are equivalent or not. Either make the denominator same or else reduce them to the lowest term. I hope the concept is had made the concept easier and we have understood the things. So we'll do one thing. We'll bind up our no, a class here, and we'll meet in another video. And yeah, we'll start from here because I don't want to make it a big one, and somewhere we get lost. I don't want that to happen. So we'll do one thing. We'll start our concept from here. Yeah. So yeah, fine then. I'll see you in the next video, in the next class. Thank you.